So as a follow-up to part one, we were looking at the relative weightings that we can assign certain observations in order to predict whether or not Sally wants to make the conscious decision to go outdoors or not. So we looked at 5 examples of a Monday, Tuesday, Wednesday, Thursday. We looked at all the relative, the observations that are present, and we sort of assigned a very generalized preliminary weighting on each of them. So this just goes to the next example, or a series of examples where if we were to assume some of these weightings, do they coincide with the predictions? So for example, at this top sort of row here, we can see that Sally has 3 friends. So 3 friends are outdoors, and we're going to assign just as a preliminary idea, 2 positives. So we're going to associate that with 2 positives worth of behavior. Additionally, she has homework. So we can, at the beginning, we're not quite sure, so we're going to assign that 2 negatives. Additionally, the sun, it's sunny outdoors, right? So we can we don't know if it's, if it's a great positive or great negative. When we looked at the table, the last presentation, we noticed that give or take maybe makes a difference or not. So we're just going to assign it 1 positive to begin with. So we can look at, we have 2 positives plus 2 negatives plus 1 positive, meaning the net decision that we predict her to make is to go outdoors. But Sally on the right tells us she actually doesn't want to go outdoors, so we were wrong about our relative weightings. So we can go at the next example where, okay, so we can assume she has 3 friends. We'll keep that positive, but maybe we really didn't, the impact on homework wasn't exactly what we thought it would be, right? So let's just say when she has homework, she really doesn't want to go outdoors. So we can assign it a weighting of 3 negatives. And additionally, it's sunny outdoors, but give or take, maybe she doesn't really care if it's sunny outdoors. Maybe she likes the rainy days as much as the sunny days, so it doesn't really make an impact to her. So when we sort of make a summation of the 2 positives, subtract 3 negatives and nothing for the sun, the net is -1. So we predict that she doesn't want to go outdoors. And in this case, we're actually right. She does not want to go outdoors, and she really does not like her math homework. But the thing is, we actually don't know if it was the homework that made a difference. Again, we're playing with the weightings, and who's to say that, maybe we overestimated the impact of the friends, right? And it wasn't just the homework. So we really don't know. So one of the things we can do is we can look at other examples of where her friends are there or not there, or it's a sunny versus a rainy day, and then we can sort of make that generalization much more than a generalization. We can actually say for sure that it predicts her behavior. So clearly, friends and sunny is not enough to change Sally's mind. So what we could do, which would serve to test that hypothesis, is that if we assume that homework, is what really impacts her behavior, we can have an example where she has no friends versus all her friends and see if that makes a difference. And conversely, we can also look at an example where it's sunny outdoors versus rainy outdoors. And in both cases, Sally does not want to go outdoors. So we can sort of see that if that's the case, that she doesn't want to go outdoors, even though all her friends were present for the second example here, right? And again, we don't know what the weighting is. We can sort of say for sure that there's a strong impact due to homework because we looked at use cases where all her friends were outdoors. So regardless if that was 5 positives, it didn't make a difference, right? So even though we assigned 2 negatives here to both of these, to the homework versus not having homework, we assigned having homework 2 negatives. It's very clear that whatever the impact of homework is, it's not as important as her having friends. And again, the rainy and sunny doesn't seem to make an impact either way. So we can continue this process of trial and error of looking at her past behavior, assigning these weights until we can tune the weights to such a point where we're right as much as possible. So we can guess with good accuracy what Sally will do based on her history. So if we did the guessing and checking, we saw she had three friends, assigned those 2 positive. She had no homework. It was sunny. And here we added the television where she doesn't have, her favorite show is not on. So we assigned that a positive, meaning a positive, a need to go outdoors. It turns out that we were right? So the final step is to predict a future day. So we can look at the past examples, look at the weights, see that they have a good accuracy on what we've seen before. But what matters is that we can predict future behavior. So we can look at a Saturday or Sunday. So for example, here we have all her friends are outside. She has homework. It's sunny, and her favorite show is on. But for some strange reason, we got the answer wrong when we tried to predict Saturday or Sunday. So that's very interesting. So when we looked at the examples in the past, we saw examples where she had all her five of her friends. So we guessed and checked, and it did make a big impact. She did want to go outdoors. We did look at examples when she had homework, so we assigned those big negatives because every single time she had homework, she stayed indoors. So it was very clear that we've looked at those examples. Additionally, we've seen examples of it's sunny versus non-sunny. But we really didn't look at examples of when her favorite show was on. There might have been a few examples where we saw examples where her favorite show wasn't on and she went outdoors. But did we really look at examples when her favorite show was on? Um, right? So maybe we didn't in fact look at enough examples. So the question is, can you figure out a reason why we are wrong about Sally? And the answer is yes. We can look at Sally's favorite show and maybe the impact that had on our predictions. And the answer is that in reality, we really only looked at days where Sally didn't watch television. So we didn't take into account days in which Sally's favorite TV show was on. So what we did was we looked at the model, or we looked at the past observations, but we didn't have a very good subset of examples that really encompassed all the different variations of these observations. So yes, we did look at examples where Sally's television show wasn't on, and we assigned it a positive, and it coincided with good accuracy for all our past observations. But we didn't take into account that when Sally's favorite TV show was on, perhaps it was her favorite TV show of all time, and it only showed during the summer when we were looking at our observations, where the weightings for her TV show being on was in fact six negatives. So it actually would um, it would take into account the fact that even if all her friends are outside, it didn't matter. Her favorite TV show was on, so that was what made the impact. So we actually underestimated how much television played a role, and it was because of our lack of generalized observations. So next time we want to make sure we have a well generalized data set that includes all types of observations: 0 friends, 2 friends, 3 friends, 4 friends, and alternatively TV show, non-TV show. We want to get as many types of observations as possible because we want to refine our model as best as possible on past behavior. So we want all those examples. So Sally's favorite TV show is Powerpuff Girls, so it makes sense she'd want to stay indoors. So just as to conclude what we've learned in this presentation series. So when we want to make predictions, one of the first things we want to do is we want to grab a set of observations, because the best prediction of future behavior is past behavior. And you want to get as many different types of observations as possible. So whether or not she has homework, the number of friends she has, television show on or off, temperature, sunny or rainy, and we can even look at other types of examples, observations that we really didn't look at in this presentation. But the more we have, the more we can test and the more we can play around with. Additionally, we want to look at the history of our observations and to develop that intuitive understanding of the observations and how much impact they have on her behavior. So we sort of assign these rules as sets of weights. So we can sort of say, we call them weights because they're sort of positive and negatives, and they provide a weighting for exactly what impact those observations have on her behavior. So outdoors versus inside is what we are predicting. Outdoors, indoors. And the weights, can either be positive and negative, or 5 positives, 5 negatives. So they have weights as well. And we want to make modifications to our weights because we want them to match the observations as best as possible. Because the best prediction for future behavior is past behavior. So we can assign those weights until they coincide with a good accuracy on our past observations. So we test our weights on examples we have never seen before, like a future event or past one we haven't seen before. So we gave the example where we looked at all the past observations in order to predict Saturday and Sunday. But there's nothing that actually says we couldn't test or evaluate our weights on Monday, Wednesday, Friday, and test our predictions on Tuesday, Thursday. So there's nothing that says has to be future behavior. What we could actually do is take a certain subset of those observations in the past, remove them from our training, and then test on them in the future. And as you know, we gave one example of a model performing poorly. If it does perform poorly, chances are we have not seen enough observations, so we didn't have a good generalization for what her behavior was. Or we just haven't seen enough observations at all. So in this example, we didn't see her examples where her favorite television show was on. But in some examples, maybe we just have examples of Tuesday, Thursdays, right? We don't have a good idea on her whole past behavior. So our model is poor when we don't have those observations available to us. And what's important is more data. There's no harm in having more data, and representative data for all the use cases is what's important. So with that, thanks for joining us, guys, and we'll see you in part 2 of our series on intro to machine learning.